I hope everyone knows that today is the last date for submission of third assignment. There is no confusion and you need to simply upload the PDF of third assignment on the folder जिसका link you have already given to me. So in the previous lecture we have seen the solution, that is we have designed the PDA for this sum a raised to n x. This is the diagram. Now we are considering the next sum, and all the sums which we are solving or designing PDA for have a unique logic. So if you prepare these 8 or 10 sums, mostly for rest of them the logic will be repeated. So you need to practice this 10 sums sincerely. The logic of each and every one will be different. So 7 sum says that design PDA that accepts language. The language is defined as a raised to n, b raised to n. Let me highlight this. A raised to n, b raised to n, c raised to n and d raised to m. A and b have power n, c and d have power m. It is given that n and m both are greater than or equal to 1. At least one A, B, C, D should be there. So when you analyze the format of this language, you will find that the smallest string which is valid and will belong to the language as per the given format is ABCD, wherein you consider the value of n and m as 1. So first thing is to analyze and find out, as always, the valid strings and invalid strings. So here we have listed 2-3 points that n and m are at least 1. So smallest string accepted is ABCD. Then if you look at this format carefully, you will find that number of A's and B's are same, whereas number of C and D are same. But there is no connection between N and M. It's not given that whether they are equal, whether N is less than N or whether M is less than N. No connection is specified between N and M. So only point you need to remember is number of A's and B's will be same, number of C's and number of D's will be same. Right. So what you will do, you will be adding all A's on the stack, and then for each B encountered, one A on the stack will be popped. Thereby you will be verifying equal number of A's and B's. Then once you are done with A, B substring, same logic will be applied to CD. And same thing is listed here. Number of A's and B's are equal. Number of C's and D's are equal. You need to write it in this way only while writing the answer for such kind of design problems. We have highlighted that N and M are not related. Logic starts from here. Add all A's on the stack. For each B of one A, again add all A's on the stack, and for each D of one C. So now let me share the rather I would share my screen so that we can switch in between the I hope now the Excel file या फिर Google Sheet is visible. So we will start with the designing part of example number 7. If I can zoom a bit, let me zoom. Okay, this seems to be fine. Can we copy the sum? Let us try to copy. This will create a problem. So, if possible, I will snip it. Snipping is being done. We will consider valid strings. Minimum is ABCD as it is specified N and M. Both are at least 1. If you consider N to be 2, double A, double B, M can be 1. Similarly, N can be 1, M can be 2, and so on. If we consider few examples of invalid strings, we can say that there is no AB and only CD is appearing. N cannot be 0, so this will be invalid. Similarly, there is only AB, no CD. AC, BD as the sequence is not maintained, or BCDA or ABC is not at all there. So these are the few examples of invalid strings. Now consider one valid string W is equal to say AA, BB, and then there is C and D. This is blank cell which should be represented using epsilon. कहाँ पे इसका sheet is next like this PDAS epsilon. We start with the stack position, suppose likewise in the initialized condition Z0. What strategy we have considered? That every A will be pushed to the stack. So right now you are processing. Let me copy the arrow also. Did I this? Can I insert one? In अच्छा, I can मतलब कैसे करना है? Leave it. We will consider this is the highlighted portion which we are processing. So A needs to be pushed here. So we are adding A on top of the stack. So what transition definition you will be writing related to this? If we can quickly consider, you always start in Q0. The current symbol you are processing is A. Top of the stack is Z0. Right? What action you have performed? All the A's to be pushed. So we will remain in state Q0. Right? And what we are doing? We are adding it to the top of the stack. So we write it likewise. This is the transition definition related to this action. Now this is the next symbol to be processed. A. Again, all the A's are to be pushed. So this will be the stack content. A will be added here. Now for this, what transition definition you will write? Write it freshly. You are still in Q0. You are processing A. Top of the stack is what? For this, it's A. So you write here A. What you do? You remain in Q0 and you add this A to stack. So this is the transition definition related to this action. Now next, B is the symbol to be processed. What we have decided, as soon as you encounter B, as you need to check whether B is appearing for the same number of times as that of A, you should delete one A from stack. So here if you delete this one A from stack, you are left with single A on this stack that will be top of the stack. So what action you have written for this? If we can wrap this, यहाँ पे हमें लिखना है, अभी zigzag manner में लिखेंगे so that it won't be like congested feeling नहीं होगा. It will be sort of neat and clean. यहाँ पे you are in Q0. Which input symbol you encounter? B. What is top of the stack? Top of the stack आपको यहाँ से देखना है. इसके लिए top of the stack यहाँ से देखना है. Top of the stack is A. What you are doing now? This is a new input symbol. So we will change the state to Q1. What is our aim? Action taken related to this is delete A from top of the stack. So here you need to insert epsilon. Which shows that you are copying and let us apply test wrapping for all of them. I hope this is understood. You are in Q0, you encountered B. While top of the stack is A. क्या करना है आपको? ये A strike off करना है एक B के लिए. Means pop it from the stack. So you say you change this state as new input symbol is encountered and popping is denoted by writing epsilon here. Now next symbol to be processed is this B. Top of the stack is A, and which state you are in? You are in Q1. I hope people are connected. I have provided mics also. In case of any confusion, you should ask. So you are in Q1. You encounter B. Top of the stack is A. You stay in Q1 and you delete B A. Q1 comma B comma A is equal to Q1 epsilon. So what will be the top stack visualization? Likewise, what will be the top of the stack? Now Z0. So as for two B's, two A's got cancelled. At this point, you are sure that equal number of A's and B's are there. Now stack is in the initialized position. Next symbol you encounter is C. Top of this stack is Z0. You need to repeat the same logic as that of A raised to n, B raised to n for C raised to n, D raised to n. So this C will be added to top of the stack. So you add C here. You are in which state? Q1. So what you will be writing? You are in Q1. You encountered C. Top of the stack is Z0. What action you will take? As new symbol is encountered, let us switch the state C to Q2 and add this C to top of the stack. Q1 comma C comma Z0 is equal to Q2 comma CZ0. In case of any sort of confusion, you should ask. Mics are provided. Next is B. You are in Q2. You encountered B. Top of the stack is C. What you will do? As new symbol is encountered, make it Q3. And for this D, you need to delete one C from the stack. So you will be adding epsilon here. That means delete top of the stack. And stack will now look like after deletion. Let me take this only and show you we have deleted this thing. Q2D comma C is equal to Q3 epsilon. Next symbol to be processed is epsilon. And stack is in initialization format. So no input symbols on tape as well as no stack symbols on stack. As in initialization is there, but the ones you need to process are not there. So this is empty stack condition. So this will be your accepting case. If such case has occurred, you say that equal number of A's and B's were there and equal number of C's and D's were there. So here, as you are in Q3 and found epsilon, let us copy epsilon. You change the state to Q4. You are processing epsilon. Top of the stack is Z0. What you can do is you stay in either Q4 or if you wish, you may change the state Q4 and let the stack be empty. So let it be Z0. So here it will be same as that of previous. So this is how you write the visualization of processing of the valid string. Invalid can also be there, but here we are defining the transitions. Valid transitions are only added, so we have considered this. Now, how you will design this? Let us copy states. I hope this is visible. So this is our text. This is our Q0, right? Anyways, this is our Q0. शिफ्ट कर लेते हैं ताकि we can increase टू आर Q0. Q0 पे हमें क्या करना था? Can I switch to tab? ठीक है, Q0 पे we are adding all the A's to the stack. So यहाँ पे I need to write that if it is A, Z0 is top of the stack, then A Z0 will be the transition definition. For next A, top of the stack will be A. This will become AE. As soon as you find B, what we will do? We will switch the state to Q1. So यहाँ पे we will be writing the transitions that if I find B, top of the stack is A. So I need to epsilon आना चाहिए यहाँ पे. Epsilon कहाँ से मिलेगा अभी? ठीक है, anyway हम epsilon लिखते हैं. This thing also made me font. There is second B. Top of the stack will still be A. So यहाँ पे नहीं आएगा. There should be the loop. Second B के लिए there should be the loop here, and it will be performing the same operation, deletion of A. I hope people are sitting with pen and paper and trying to define these transitions. So multiple B's के लिए multiple A's will be deleted from the stack. Now you will encounter C. As soon as you find C, you will change the state to Q2. जैसे ही आपको C encounter होगा, what will be the transition? That you encounter C, top of the stack is Z0. What you do? You add C to top of the stack. And for multiple C's, same thing is repeated. So multiple C's. Next time you will find top of the stack is C. Second C के लिए it won't be Z0. So all the C's are added, and finally you will have this thing only, that From Q2 we have encountered D now. So as soon as we encounter D and top of the stack is C, you will be deleting that C. All subsequent keys are deleted for each D encountered. This is your C3. And excepting case क्या हो रहा है? Excepting cases Q3. What we are writing here? That we encountered epsilon as the next symbol. Top of the stack is 0. What you do? Let it be 0 and go to final state. So here you can make this C as the final state. This is one kind of, whether we can send it behind. So this will act as final step. Now if you want to accept using empty stack, so what you'll do, you won't make this Q4 a final state. Rather it will stay as non-final state. Or instead of adding, it will be, you need to add this. Otherwise, for less number of D's, it will accept. 7. Now both of them are in sync. Let me delete this. You try to they are in one screen right now. You try to relate this transition definition. This is Q0 AZ0 gives you AZ0. Q0 AZ0 Z0. And next is Q0AA is giving you Q0AA. Q0AA is giving you Q0A. Then you encountered B in Q0. So Q0BA is Q1 epsilon. So this is that transition. Next is Q1BA, Q1 epsilon. Q1BA, Q1 epsilon. Then is Q1C Z0 is Q2C Z0. So this is Q1C Z0. You are reaching to Q2, C is added. Then Q2DC. यहाँ पे we have considered single C. So this loop का transition when top of the stack is C is not there. Q2DC. This is Q2DC, Q3 epsilon. So it is reaching to Q3 and this epsilon we have written. In Q3, यहाँ पे क्या लिखना है? Q3 not Q4. In Q3, if you encounter epsilon while stack is in the initialized condition, you go to Q4. So here you can validate these things and this will be the PDA design. Now coming back to the sum, whether it is asking you to design a particular kind of PDA which accepts using final state or empty stack, nothing as such mentioned in the given sum. So you will be using this diagram which accepts using final state. Any doubt, any query related to this? Take a minute and go through the complete solution. Solution we have started with this. After writing these bulleted points and visualization of stack in such way, you have constructed this diagram. Same is given here. Now explicitly we have mentioned that A, C, Z0 are the values of gamma stack symbols, whereas A, B, C, D are the sigma value, alphabet values. Right. Now, next sum. This message is not for me. Next is sum number 8. I hope there is no doubt related to the logic. Now again, 8 number ka variation uses the logic of above, but still it differs. It will have some new things to design. Go through the sum. It says that you need to design PDA for the language wherein the word format is A raised to I, B raised to J, C raised to K, where I, J, K are 0 or more, but the constraint is K is equal to I plus J. Now in such cases, you need to first analyze what are the valid strings, invalid strings. You should get the format of language properly. So if you consider I, J, K can be 0, I to be 0, J to be 1. So what will be K ka value? It will be 1. If you consider I to be 1, J to be 1, K ka value should be 2. If you consider I to be 2, J to be 1, so 2 plus 1, K ka value should be 3. So first you need to list out the valid strings and invalid strings. Again, as I, J, K power values can take 0, A can be absent, B can be absent, C can also be absent. In case B is absent, A and C will be equal. So this sum will be like A raised to N, C raised to N. Whether C can be absent, C can be absent in only one case, when I and J are 0. I and J are 0 means A is absent, B is absent. So there is only one case when C will be not there. Otherwise, you can have A raised to N, C raised to N, or B raised to N, C raised to N. Or if all are present, K will be I plus J. Again in sum, they are saying that find the PDA accepting through final state, and second, find the PDA accepting through empty stack. Now here 95% of the designing part will be same. Only towards the last state there will be variation. So valid strings we have listed, invalid strings we have listed. 1 plus 2, 3 C's are there. 2 plus 2, 4 C's are there. A is absent, so B1, C1. B is absent, 1A, 1C. Epsilon is also valid string because IJK can be 0. Invalid strings A1, B1, C1. Why this is invalid? Because if there is 1A, 1B, so there should be 2 number of C's. Missing of C is also invalid. A, B, triple C is also invalid because number of C's required here are 2. Number of C's required is 2. 1 plus 1. So after listing valid and invalid strings, now we are listing the logic. So as we have analyzed what is the connection between I, J, K, your ultimate aim is to check whether K is same as I and J. So what you'll do, I number of A's will be added to stack. J number of B's will be added to stack. So instead of adding now A and B, you will consider some symbol say X. For each A, those many I number of X will be added. For each B, J number of X will be added to stack. And then for each C encountered, one X will be popped. So take a minute, read this. These three bulleted points. What it says, push X on stack for each A in input. Push X on stack for each B in input. And then pop one X from stack for each C encountered in input. So those who want to design, take a minute or two and try to write or draw the visual representation as well as diagram, transition diagram. Take a minute or two because this is the 8th sum we are solving, designing sum. So by now I hope you there will be a sufficient visual practice for you. So it's time to now do the actual implementation with the pen and paper. So try to draw. In case of any doubt, you should ask. Mics are provided. Logic is written. Let me highlight this logic. So what you'll do, how you'll start, you'll take one valid string W. For each input symbol from left in that W, try to draw stack visualization. What action is performed? Write related transition definition. PDA and Turing machines are the highest marks carrying topics from TCS. 20 marks for PDA, 20 marks for Turing machine. So 50% of the weightage out of 80 is given to these two topics. I hope you are able to lecture. I hope you people are trying. By that time, let us name the entire thing. That also we can do. Everything will be snipped here and यहाँ पे paste करते हैं. This is our 8th sum. Right. So आपको विजुअलाइजेशन में क्या करना था? W equal to a valid string लेना है. Anyone would like to tell me the example of valid string? which you want me to trace. E, B, B. So 2 plus 3, 5 C's should be there. 5 हो गया, and this will be epsilon, right? ऐसा कलरिंग कर देते हैं, so we can differentiate the symbols, right? Now, considering some stack with Z0 initialization, what we have decided, push X on stack for each A as well as for each B. So जैसे ही आपको Q0 में A is encountered, that is added to stack. Instead of A, we are adding X. Next you encounter again A. For this A also, we are adding 1X to stack. For B also, we are adding 1X to stack. Next is B. Same action will be performed. This is fourth symbol, so you find 4X. Fifth symbol, which is B. Fifth symbol, 5X on top of this stack, right? Next is C. What we have written, pop 1X, ये highlighted वाला blue, pop 1X from stack for each C in input. So 1 of the X will be deleted. And same action will be performed for all subsequent C's. So if 5 C's are there, 5X will get deleted one by one from top of this stack. And thereby, without counting, using mechanical technique, you are verifying their number, their count. This will be deleted. For next C, we are copying this as it is, और उसमें से X is deleted. We are not counting. For this, we are copying this as it is, and X is deleted. And then you reach the accepting condition that there are no more input symbols on the tape. Stack is also empty. So these numbers got verified and you can now accept this string. Means K is equal to J plus I. Now, how you will write this transition? Q0 comma A comma Z0. So you write here Q0 comma A comma Z0. A in Q0 itself. Add X to top of this stack. समझ रहा है? आई होप यू पीपल आर गेटिंग दिस थिंग. Mics are provided. You can ask the doubt. सेकंड में क्या हो रहा है? You are staying in Q0. You are processing A. Top of the stack is X. What you are doing? You are staying in Q0, adding one more X to top of the stack. B के लिए क्या हो रहा है? You are still in Q0. You encountered B. Top of the stack is X. You need to add this B in the form of X. So you stay in Q0. If you wish, you may change this state. You may change this state. Q0. Next B के लिए whether same thing will be performed? Yes. Next B के लिए whether same thing will be performed? Yes. And then you encounter C. If you encounter X, change the state to Q1. क्या करना है? आपको डिलीट करना है वन X from top of this stack. So we will be adding this epsilon symbol here. Now you are in Q1. You encounter C. Top of this stack is X. What you do? You stay in Q1 and you add. And same thing will be done for subsequent keys. And here is your accepting state that you encountered epsilon while you are in Q1 and top of this stack is Z0. So what you say depends whether empty final state पे जाना है या empty stack condition. So very quickly we will design for this. Take a minute, go through this visual representation. And by now I guess it's quite easy for you. Q0 में if A and B are encountered, they are added to A, Z0, X, Z0. A is added. A is absent. B, Z0, X, Z0. Second A, so A is the input symbol you encountered. X will be top of the stack. Till you are adding X, same thing with B. Second B, top of the stack is X. B is added in the form of X. As soon as you encounter C, you change the state to go to Q1. Then if you encounter C, top of the stack is X. What you do? Epsilon. Pop करना है 1x from top of the stack. So we write epsilon. Now this will be done multiple number of times. So we are adding self loop for this. Every time you encounter C, X is on top of this tag, delete that X. So when equal number of X are appearing as that of C, then the condition which you will reach will be input tape is also empty and stack is also empty. So in that case, you go to Q2, that you encountered epsilon you go to Q2, which is your final step. Now here, if A is absent, still it will execute. If B is absent, still it will execute. But still this diagram is invalid. Anyone would like to give me the reason why this diagram is invalid? 50% of diagram is correct, 50% of diagram is not. Anyone would like to discuss the reason? What is the mistake in this diagram? Mics are provided. At least it may be wrong, but at least show your understanding. Yeah, if this diagram is right, what do you feel? I am not adding save close नहीं कर रही हूँ because we may need to modify अगर इसमें कुछ mistake होगा तो. Do you feel there is a wrong interpretation as per this diagram? I hope people are connected in the sense physically they are present and connected, so most of them are there, but they are sitting and listening. So try to think over this diagram and tell me whether this is correct diagram or not. Let us say save and insert. Try to think over this diagram. Let me share by that time the attendance ka link. I will let that diagram visible on your screen. कौन सा screen है वो? Why it is switching? It's a Chrome tab. I hope this diagram is visible to you. Think over this and analyze. By that time, let me share the attendance link. Just a reminder that today is the last day for submission of third assignment. The form, Google form for submission of link is also active. Only once you need to upload. 81 students have uploaded that link. Only one student is remain. And जिस folder का link you have uploaded, उसी में you are supposed to copy the PDF of third assignment. Any doubt in the sums we have seen till now? Mics are provided. This is the sum. This is the sum a raised to I, b raised to j, c raised to k. You need to draw two diagrams, one for final state, one for acceptance through empty stack. Whether anyone feels that this is not a proper diagram or this is the proper designing of PDA. If no doubts, you mark your attendance and you may disconnect.